Acha ijaribu connect na kuambia tu. Tumeanga ni mrefu sana.
You have borrowed 1. It comes 8 is 8.
Naona kitu kama hiyo.
Hii tumeborrow huko juu tena. Tuna strike off.
Hapa ni kama imepick. Sasa naenda YouTube yenyewe.
Sasa kwa YouTube hapo kwa channel
strike it off.
Imeanza.
And here we remain with
make sure your Google iko selected copies.
Hii link yako unakopianga wapi?
Kwa YouTube click kwa
hiyo copy video URL.
Here we remain with the 7.
Sasa hii lazima nijitumie kwa email.
But you borrowed 1. So you borrow 1, that's why it is becoming 7. Ukiborrow 1 hapo inakuwa. So you borrowed 1 from here, so ikakuwa 7. Then what you borrowed here comes here to be 8.
Compose
is now 8.
Alafu nianze na class reps,
Because that's what you have borrowed, now it becomes 8. 8. So now
inafunguka tu direct.
So now it will be 8 plus.
I hope utatest. Na ninaweka window gani kwa juu?
So you do 9 minus 5. 8 plus 1 is 9. So 9 minus 5.
Nasema window gani inatakana ikuwe juu?
9 minus 5. 9 minus 5 gives you 4 here. Here it will be 4.
Ndio hii. Naona.
Then 7 minus 6 gives here 1.
Na ilete hiyo.
Then 7 minus 6 gives here 1. And then 6, this 6 minus 0
nileta kutoka kwa OBS. Can capture because
so that will be the answer for that particular.
Lakini bado ni hiyo tu. Nijaribu hii.
So that's how you do binary addition. Every time you are borrowing, you borrow 1 but it is now.
Nani ameishikilia huko?
It becomes to 8 as you subtract.
Peter anafunza.
So that is now where we have finished. So we go to the next.
Okay.
The next thing we are going to is what we call the hexadecimal. Hexadecimal is base 16. Hexadecimal runs from 0 to 16. So all the numbers 0 to 9, then 11, then 10 is A. B is 11. C is 12.
Yeah, I tried logging. Okay, we had some challenge. With the network.
D is 30.
Let me just check again. Okay, let me just check and give you a call now.
Undo. Let me undo. 15 is F. So it runs from 0 to 9. So the number 0 to 9. Then when you reach 10, for hexadecimal, it is equivalent to so this is hexadecimal. So we are talking about hexadecimal here. So now let us see how to convert a number into hexadecimal, because all the hexadecimal numbers run from, I've told you they run from 0 to 9. There is no 16, but now this is what we call base 16. They are actually base 16. So let's start with the conversion into binary. So we want to convert into binary a number like, maybe let us take a number like what? any number like 1,000. So we have like 1,000. So let me use what I use here to convert. So we want to convert a number like 1,000. A number like 1,000 into hexa. Into hexadecimal. We want to convert a number like 1,000 there into hexadecimal. So here we start with 1,000. Sorry. This is base 16. So hexadecimal we divide by 16. So we say 16 goes into 1,000 how many times? 16 goes into 1,000 how many times? So you take 1,000, you divide by 16. It will goes there 62 times. So you write here 62. 62. Then you look for the remainder. So 62 times 16 gives you 992 minus 1,000. So here it will be rem 8. Remainder 8. Rem 8. So that's the remainder. It will be rem 8. Then 16. 16 into 62. 16. Again, you take 62, divide by 16. So it comes here 3 times. It is here 3 times. 16 times 3 is 48. And 48 minus 62, the answer is 14. So it goes 3 times and it remains 14. So you don't write 14 here now. I said when you reach 10 is A. B is 11. C is 12. $13. So I just want to remind you what we've said here, because now a remainder, before we go back, I said here, I've said here that 14 is E. A, B, C, D, E. 14 is E. Then F is that. So when you cover remainder and you get it's 14 here, you don't write the 14. You say rem 14, which is E. Is capital E. The remainder here is E. And then 16 into 3 is 0. Rem 3. Rem 3. And 16 into 0 will be 0. Rem 0. So the answer now, you write it upwards. When you write the answer upwards, it will be 0. It will be 0, 3, E8. So this into hexadecimal is 0, 3, E8, base 16. So superscript, no subscript. Subscript. So that's the answer. So that's the answer now. We have 3E8 base 03E8 base 16 is the answer to that. So that's now the conversion. So you read upwards. So we can also convert. Now we can convert. This was 0, 3, E, 8. I convert that into decimal. That is base 16. I convert that into decimal. That will be very easy again. So here you will be multiplying by 16. Let me remove this. So here it will be base 16. So you want to convert that now into base 16. Let me just delete, then I start afresh. So we are converting this. So we'll start from the extreme end. So the first thing will be, we say 8 times 16 power 0. So power 0 here. So it will be that plus, then you go it will be 16 power 0. Then next it will be E. It will be E. It will be E times so e to the power of 16. So plus, next, Next it will be 3. Sixteen power 2. Now you multiply by 16 power 2. Then it will be 0 times 16 power 3. So now you add. Here it will be plus 8. Then it will be 16 power 1 times 14. Now the E is 14. So you must always remember that that is 14. It will be 14 times 16, which comes to 220.
Yeah, including houses, as I said,
224. Here it will be 224. Then 16 power 2. 16 power 2. 16 times 16 is 256. 256 times 3. 256 times 3 gives you 768. Then here it will be 0. It will be plus. So the answer here, it will give you what? It will be 768 plus 224 plus 8. So it gives you 1,000. And this is base 10. 1,000 base 10. So I put so that I can show the sign. It's base 10. So that's how it comes there. So we took 1,000 and we have converted it back into. Now, even if you are told to convert this into binary, you can convert because you know 1,000, it's easy, you divide by 2. You can also convert it into octal. Once you have the decimal, you can convert it to anything. So that is it. Now, so let us look at now what we call decimal subtraction. Decimal, that was, I think we need to go now to addition. Then from addition, we go to subtraction. So we can compute that. Let's look for space. We can compute that. It means at a table here. Mark D, are they getting? Mark D. McDonald. McDonald. Are they getting?
Yes.
Yeah, so we move to the next. So we have finished that. So let us compute now the addition and subtraction. So we want to add and subtract. So I think we start with addition, hexadecimal addition. Let me delete and create space here. So I think let us start with the subtraction and then we go to addition, or we start with addition, then we go to subtraction. So we want to add two numbers. So for example, you can have F F 0 0. So 0 1 minus A B. Now these are two numbers that are in hexadecimal. So F0 1 minus AAB. Those are AAB is in base 16. FO1 is in base 16. So when you start now, you cannot, one cannot subtract B because B is the equivalent of 11. B is 11. So you cannot have 11 minus 1. 1 minus 11 is not possible. So we must borrow. And the borrowing starts from here. So when we borrow 1 here, we borrow 1 here. So if it was F, now it becomes E because that is F minus 1. That's 15 minus 1, it becomes 14. So when you borrow 1 here and it becomes, you borrow 1. Now you are borrowing here, borrowed 1. And this one becomes it becomes E. Sorry. E capital, but now I need to remove the striking format. Let me remove the strike. When it comes here now, when you have borrowed 1, it comes here, it becomes 16. So it becomes 16. What you have borrowed comes here and becomes 16. What you have borrowed here comes here and becomes 16. Format. It becomes 16. When you borrow 1 from 16, when you borrow 1 so that it go to the next side, this one will come to F because 15 is F. F. When you borrow 16, it becomes F, and F is equivalent to 15. Now, when you borrow here 1, so it becomes F. Then when you borrow this one inakuja huku, so this one will be, after borrowing, it will be plus 16. So it's 16 plus 1 is 17. 17 minus B. B, I said A is 10. So 11 is B. So it will be 16 minus 11, which gives you 17 minus 11, which gives you, because 16 plus 1, what you borrowed 16 plus this one becomes 17. So 17 minus 11. So 11, B is equivalent to 11. So 17 minus 11, 17 minus 11, you get 6. Then 15 minus 10, you get 5. F is 15 and A is 10. So F minus the equivalent, F is 15, A hapa ilikuwa E. We remained with E. After borrowing, this became E. After borrowing 1 from that, it became E. So I don't think it should be striked. It should not be striked. It is here without a strike. So E which is 14, 14 minus 10, 14 minus 10, A is 10. So 14 minus 10, 14 minus 10, you get 4. Now this is the answer for this. 14 minus 10, you get 456. So that is the answer. So that is the answer, and that is the answer for this particular one. So that's what we call hexadecimal subtraction. Hexadecimal, this is hexadecimal. Octal, it is hexadecimal. 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 Now that is base 16. What we have been dealing with here. So the answer will be that. So we move to the next. We move now to addition. Hexadecimal, which is again hexadecimal. So let me put here some few numbers, then we add. Let me add the odd numbers. A, B, and 9, B. So you are adding these two numbers. So 9 plus B, B is 11. 9 minus B, 9 plus B, that is B is 11 plus 9, that is 20. So what you do, you take 20 minus 16. 20 minus 16 gives you 4. So you write here 4. Write here 4. 16 is the big one. You carry 1 here. You carry 1 at the top. Sorry, let me create somewhere where you can carry. So B, you said is 11. So you carry 1 plus 1. So this one becomes, if you do plus 1, this one becomes B. A plus 1 is B. That one's what you have carried. So B plus B, that is 11 plus 11 is 21. 21 minus 16, 21 minus 16 is 5. So you write the remainder here and you carry 1. You carry 1 here. When you carry 1, so 1 plus nothing is just 1 here. And that is the equivalent. So there's nothing difficult there. Just adding the numbers. So now that is hexadecimal. Now you can convert hexadecimal to octal. You can convert to binary. You can also be given an hexadecimal number and you convert it to binary. The one way is to make the number, if you have a problem, convert the number first to decimal, that is base 10. Then from base 10, you can take it to either octal, you can take it to binary, and you can do the addition. So whichever number you are given, you can convert to any of them. The most important thing, just know that base 8 does not have 8. It goes from 0 to 7. Then base hexadecimal is base 16. It runs from 0 to 15. It has not reached 16, but it's base 16. So from 0 to 15, where A is 10, B is 11, C is 12, D is 13, E is 14, and F is 15. That one you need to know. I think I've been very clear there. I've been very categorical and clear. We are coming towards the end of this course. I think this is the last class we are having. Tutakutana tena. So tutakutana tena, but next week we have a cut before you go home. Next week will be on next week we'll have a cut. So be ready. Read the notes. Mostly it will be calculations. Calculation inaogopesha wengi, but that's how it is. People must do calculations.
Daktari.
Yes.
yeah, students have been following. So next week they shall have a cut, and if possible, most
You
are
say?
maybe most are requesting that we shall give them the
They do
cut
what?
as planned. We shall give them a cut as planned.
You are saying you are not audible.
I'm saying,
1 minute.
I'm saying,
Let me increase my. Okay, now come again.
I'm saying we shall next week they shall do a cut. Then I'll be able to provide them with some revisions, especially on a number system. We have some revisions that they need to practice.
Yes.
Yeah, so let them not be worried. If possible, maybe we can have a session like 2 hours after the cut. Then I will guide them on what we have covered so far. So let them not be worried about what we have done today.
But I think online we have, okay, if you go online,
yes,
all the notes are online, and also we have examples on YouTube. I think YouTube can show even how to do the calculation, what I've been doing.
Exactly.
Is that okay?
It's okay, it's okay.
Ikoswali. I think this one marks the end of the class.
Yes, they can now interact with the system. We have some good notes that you posted there. At their free time, they can go and access the content. We shall also provide them with more revisions, because now we are calling off the end of the sessions, the lessons. So they will, although many revisions, as you have said, are found on YouTube. Students, let you not be worried. Just go to YouTube, search for any video, any demonstration is readily available. But we shall assist you whenever may be necessary.
I think that one marks the end of binary.
Yeah.
The rest that is in the notes, you read and finish.
Have you covered? Did you cover computer networks? Huh?
Yes, I finished.
Okay. So next week, as we agreed, students, very early in the morning, as we did last time, we have a cut. Then maybe from 9 there, we can have a session just to wind up what we have covered so far.
And those who missed cut 1, they have a 0 plus now what they are going to do. It will be 0 plus what you are doing.
Sure.
So if you didn't do a cut 1, we'll just put you a 0 plus. That is it.
Yeah, so I will open cut 2 very early in the morning, as early as 5. So those who oversleep, kitawazamba 10.
Or you'll open the cut between 5 and 5 a.m.
Yes, 5 a.m. to maybe up to 7, so that by 8 they are doing something else, or by 8 we start a revision with them again.
I think for me, I've finished. I'm done. I'm done with them.
Sawa.
I'm calling you, Makdi, just in a minute. Sasa unajua mimi sijajua bwana. Sasa watoto pia wako na vizuri. Na mbona wakusema na niliwapatia magadi. Mbona hawajaniambia mimi? Mzahulu. Na vijana mbona hawakusema kulikuwa na shida na eLearning na eLearning wajaliambia ni walienda wakaambia marketing kawaambia vile wana login. What happened?
Unajua sasa watoto they are very funny because wananiambia today morning. Hapo wananiambia they have been trying to reach you, they don't get you.
Nipatie namba ya class rep.
Acha nikupatie namba ya huyo. Because unajua students wanakuanga fudimu sana.
Na unajua unajua notes nilifundisha paka week 4 na nikawaambia hizo zingine wanasoma online wakifanya. Sasa system pia unajua hii system pia kutoka ocha akuje bwana, it's not very good. Unaelewa? Iko shida.
Iko shida. Mimi nimewakomanisha kidogo nikawaambia.
Kama maana hata hiyo notes zako restore online. Kama maana ndio kwa